Good evening and welcome to the BS and Beer Show. BS stands for Building Science, of course. Tonight's topic is building diagnostics and new construction. My name is Mike. I'm a residential designer in Maine. Tonight I have an empty glass of water, so I'll fix that during a break here at some point. BS and Beer is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom show. The Brew Crew and our guests volunteer our time each week to bring you what we hope is a fun and informative discussion. We'd like to thank our media sponsors, Green Building Advisor and Fine Home Building Magazine, who help us produce and promote the show. And with that, I will turn it over to Emily for announcements.
Hey guys, Emily Mottram. Tonight, in honor of Travis, I made sure I had beer. We've got some gluten-free omission pale ale tonight for the show. So having a beer tonight. If you guys are seeing it on the bottom of your screen, if you're new to Zoom, the chat box is probably already blowing up. Make sure in the chat box you pick either everyone or all hosts and attendees, depending on which version of Zoom you have, or only the panelists will be able to see your comments. So we encourage you to introduce yourself in the chat box and what you're drinking, or just say hello to your friends so they also know that you're here. Fine Home Building sends out a Zoom reminder every week. That is just the link to show up for the show on Thursday nights. If you'd like to know what the show topic is and who our guests are going to be, pop over to the bsandbeershow.com and join our mailing list, and you'll get a weekly mailer that talks about the topic and what we have planned for the show. Video recordings of the show are available usually on Friday after the show on our YouTube channel, the BS and Beer Show, also on the bsandbeershow.com and on Green Building Advisor's blog post about the BS and Beer Show. So you can catch up on any shows that you missed over on the YouTube channel. There's also an audio only version of the show available for podcast listeners. If you prefer to take in the show content as a podcast listener, it's available on Apple and Spotify podcasts. So lots of ways to take in the BS and Beer Show. Announcements: the BS and Beer Show Brew Crew is going to do 3 live events at the International Builders Show on February 8th through 10th in Orlando. So if you guys want to come and do BS and Beer with us live or just attend the show, we'll be there February 8th through 10th. So now it's off to you, Travis, to introduce our guests and yourself.
Excellent. Yeah, it would be my pleasure. I'm super stoked for that IBS thing, by the way. So hopefully we'll get a good turnout. I'm really looking forward to that. It's going to be a lot of fun. We've never vacationed together as a brew crew. And I think that this is going to have some go-karting or other sort of irresponsible family vacation vibe where someone gets injured and someone gets a story. I'm hoping to not be the injury. Anyway, I'm Travis Brungard. I'm in Kansas City, not really, Prairie Village, very close to Kansas City. Tonight, I'm drinking a V. Stephaner Hefeweiss beer. And to further alienate all of our viewers, I'm drinking it from an NBA Catwatch koozie. And there's probably like 300 people in the world that know what that is. But it's NBA season and I'm stoked. So come along, people. Tonight, I have the pleasure of introducing some very, very bright individuals, some who I know and others who I do not. This is my first time meeting Steve Rogers. Steve is president of the Energy Conservatory, and with 20 years of experience in the areas of fluid dynamics and flow measurement, he's a well-rounded engineering professional, experienced in design, manufacturing, information technology, and marketing. And Steve, thank you for joining us. Are you drinking with us this evening? It looks like you might be in the office.
I'm in the office. I've got my Henry Weinhard's root beer. It's the best. I'm a white root beer connoisseur, and it's my favorite.
I can confirm. I'm actually a fan of that. It's a quality root beer. My son enjoys a good root beer float, but if you're sans ice cream, it's still good.
Yeah.
Well, thank you for joining us. Did I leave anything critical out of your, well, it was a short intro. Do you want to tell us anything about yourself? You like to surf, long walks on the beach?
I do a fair amount of home improvement. Just finished adding about 30% to the square footage of my house. And, the new part is so much better than the 1958 part. And
the new stuff has better airtightness from my experience. Is that yours as well?
Yes, it does. Yes. And I'm just happy to share my knowledge and, contribute to the community.
Well, we're very grateful for your time and your generosity. Thanks again. Next up, I'll introduce Jake McAlpine. Jake is manager of technical support at the Energy Conservatory. and a recent visitor to the Kansas City area. Nice to see you again, Jake.
Very
He
nice
has
to
12 years experience in the weatherization assistance program, and he worked as an energy auditor and program manager for a weatherization service provider in the Minneapolis area. Jake is a great guy from the limited experience I've had with him, but I haven't told you much about him. Jake, tell us more about yourself and what are you drinking tonight?
I am drinking a Schwanttoberfest from our friends at Bauhaus in Northeast Minneapolis. They make some lovely beers. And this is a Bavarian style Marzen. So, and it's got umlauts. So I'm way off on the German side of things tonight. And yeah, I, unlike Steve, I'm that type of person who has analyzed my house and not yet fixed it, but I know exactly what's wrong with it.
You're in good
yeah.
company.
Yeah, that's where I'm at.
And congrats on the umlauts. That's always a good level up. You know, that's classy. We appreciate that.
We had there's a city north of us that it's a German name for the town, and they actually petitioned to get the umlauts put back on the sign. So now they had to redo the signs with the umlauts. So
I love that. I got to schedule a visit to that one. I also get the pleasure of introducing my friend. Can I call you a friend, Bryan, or is that a reach?
Well, this is awkward now that you've brought that up.
That's just the flavor I was going for. My friend Bryan Uhler, who would not
For
consider me a
tonight,
friend.
yeah, we'll roll with that.
Well, you've helped me on numerous occasions. I've called you directly, so I'm going to consider you at least an advanced acquaintance. But you're also part of the second generation of Pioneer Builders, which constructs custom high-performance homes in and around Port Orchard, Washington. He is a contributor. Well, Bryan is a contributor and brand ambassador for Fine Home Building magazine and an avid walker and frequent poster to Instagram, which is how I discovered you, and also technical support for my original ERV questions. So thank you for joining us and for all of your contributions. Tell us what we've missed.
Well, I don't build custom homes. We used to. We are a 100% spec home builder. So I think that's a little bit of a different perspective. I'm more of an accountant bookkeeper by trade, so I love it when I hear people in building science say, oh, it's only a couple more dollars. And I think, well, you're not a job coster, are you? So I think those two things definitely lead to a little bit of a different perspective.
Couple
That's
more
fair.
dollars per square foot.
Across how many builds, across how many years equals how much loss?
Yeah.
Are we in the red yet?
Just keep going, Travis. Just keep going.
I'll get us there. That's my specialty. Our nonprofit's always very, very busy around here. Yeah, I pulled that bio, I think, off of Fine Home Building. So we'll have to update them because I think that's where it says constructs custom. I knew you were a spec builder because that's actually one of the reasons I wanted to talk to you about stuff because of that perspective. I think you can make more of a difference.
Well, I've tried to correct it over email, I think. Mike Main said I said that last time I was here. Maybe now it'll change, but if not, it's not the end of the world.
No, you forgot to mention it when Kylie was here. We're all useless.
We have no power.
None. We'll try.
Well, I think, were we going to start off with a little bit of a presentation, Bryan? Was that kind of the game plan here? You want to kick it off?
Yeah, I don't have any images to share or anything. I'll just tell you guys maybe a story and then 3 different, oh, there you go. Thank you, Suzanne. And then tell you 3 experiences I've had from constructing houses and how diagnostics has helped. So here's the story to begin with. I'm going to guess this was maybe 4 or so years ago. We've always had our houses blower door tested as part of our building code, you know, or at least since that came in up here in Washington State. So one time I met with a blower door guy who was contracted by the insulation company. And when he walks in, like the first thing he says is, what do you want your number to be? And it took me a second. And then I realized what he meant. And I was like, and I wasn't a jerk. That's one thing I strive very hard to do. But I just said, whatever it ends up being. So he ran his test and we failed. And so then he needed to come back later. And that was kind of the first foray into what's really going on here. I started trying to figure out cubic volume for the first time. I mean, it was very much like blazing a trail through the jungle by yourself, never having done any of this type of stuff before. which I think was kind of good. You know, it was good to fail, and then it was good to try to figure some of these things out. So then, you know, that stays in your mind. It just kind of rattles around back there. And then there was an article in JLC. It was like one of those where somebody, I think, was responding to a letter to the editor or something like that. There's this big long write-up on blower doors. And one of the points that the guys made was, stop thinking about it and just buy one. And so then again, it just lodges in your head. Sometimes it takes me a while to make a decision. So a couple months later, I finally did it. And I got connected with the Energy Conservatory, had no idea what I was buying, like at all. It was so confusing for my little brain. I got stuff that I just discovered this year. It was like, oh, so that's what that thing is actually supposed to be used for. So there was one particular house. I'm just going to guess I spent 8 to 10 hours on a finished house chasing down leaks, trying to button up receptacles, caulking, you know, for miles. And I listened to Bill Spohn with HVAC Science, Building Science podcast. I spent a lot of time with that guy while I was listening to podcasts for 8 to 10 hours. But man, did I learn a lot. And so I tried everything under the sun that I could think of. And the one thing that was sticking in my brain is we always put, almost always, a ducted mini split up in the attic to distribute to the rooms. And per the IECC protocol, testing protocol, you're supposed to leave your vents open, you know, really get a feel. And it made a lot of sense to me as you're learning, well, really, that's just like blood vessels in your house. Even if it's in an unconditioned space, the air in there is still part of the whole thing. So I'm going, that's the only place that I can think of where there could be a leak. So fast forward, I meet with our HVAC contractor, and I really wanted him to test the what he was doing. He had a Retrotech system, didn't have a clue how to use it. So he had one of his guys with him, kind of the same thing. They were fumbling around. They were clearly not familiar with those tools. And I don't know if you've ever been in the case where you're trying to figure something out, and maybe the homeowner's there or something, and you get just a little quiet when you realize what the problem is because you don't really want to say anything in front of the homeowner. Well, that's what they did with me there. All of a sudden, they got real quiet as they were testing their ducts. And as it turns out, you've got your cassette in the ceiling or up in the attic. There was the supply and the return plenum. And Bob had, I would say, delegated out to one of his guys how to put it all together, assuming it was being done properly. And I think that's like one of the main lessons of this whole thing is just assuming that whoever's doing the work is doing it properly. They didn't build it right. And so due to that, when you do your testing protocol properly, if your ducts are leaking, you're going to get a bad number. So that helped. That really helped. I ended up buying a duct blaster and didn't tell Bob until later. I didn't want him to think I was not trusting him, but it was more about the results than getting on his case. All right, that's the story. Travis, am I talking too much or should I keep going?
You're not talking too much, but I already have a question. And since I can't follow the chat, I only ask my own questions. I am curious if you would have the same perspective if your equipment was in the inside of the conditioned space within the air sealed envelope. That's the way we get around the duct sealing measures here. Am I correct about that?
Yeah, I mean, check whatever your local adoption is, but I think the 2021 code, that's irrelevant. They want you delivering the amount of air to each discharge point of your ducts. So you might be able to get away with it with what your current vesting code is, but eventually that's going to be no bueno.
So
that means no good. Sorry, my Spanish popped up.
I'll give you some perspective on what the problem is, because leaky ductwork, if it's inside conditioned space, has a different symptom from leaking to outside the conditioned space. So when it's going through the attic, every CFM that leaks into the attic and rather than into the house is pure energy lost, right? You paid to condition that air with energy and money, and then it went out the attic vent. That doesn't happen if the ductwork is in conditioned space, but there's another problem that all of us in the Midwest are very, very familiar with. And that's how in the Midwest, you can't ever get the main level and the basement to be the right temperature in the summertime in the cooling season. And that's because if you got your ductwork in the floor space, and if like my house, it's leaking like 35%, then you have way more cold air leaking into the basement, because in a basement, how much cooling load is in a basement? It's like 10% of the whole cooling load. You need 10% of the air to go down there, and it's leaking 35% down there. There's no way you can keep it the right temperature. So if you seal the ductwork up, then you can close some vents and it will actually push the air where you want it to go. And you can achieve better delivery of the air where it's supposed to go. You're not losing energy, but it's a huge comfort problem.
Yeah, I totally agree with that. It's actually been part of, for Energy Star and the HERS rating stuff that we're doing, we're sealing our ductwork anyway, but it's common in my market to not do that.
Yeah.
And without the adoption of the current code, there's a lot of people still doing it that way. So I really appreciate the thoughtful response.
And if it's comfortable in the main level, you can hang meat in the basement, right?
That's right.
All right. You want me to keep going, Travis? All right, I got two other examples of things that were good to be able to find out. So I just did a test house, and we ended up having a conditioned envelope all the way through the attic, all the ducts, everything in conditioned space. And so I've been testing it from rough framing through, mechanicals, et cetera, et cetera. I think I've done 5, coming up on 6 tests. I'll do the last one at 6. Anyway, early in the process, as I'm running the blower door, there was some leakage going on. And so I was just feeling around the house, seeing what was going on. And there was a particular casement window on the hinge side that was leaking. Now, from the outside, I had seen that the vinyl didn't look right, but to me, it was probably like a trim type thing. Well, in looking at it, on the hinge side, you have these clasps. I'm sure there's a word for it, but they should connect like this, and suck it tight. Instead of being finger to finger, it was more like knuckle to knuckle. So it protruded out the window from the frame. So as I was doing the test, I just sealed it up, got a hold of the window company. And this is where the builder side comes out, because you would love everything to be engineering calcs and sterile, but no, it's real world. Interlocking flanges. Thank you. So anyway, I got a hold of the company. I had to go back and forth. They had, I think, my email address wrong for the warranty. Eventually, the guy comes out, totally doesn't take care of it. I think he wrote up the order wrong. The next guy comes out, doesn't take care of it. Had to get a hold of the company again. Then another guy comes out. Thankfully, he solved it. And he actually went upstairs and found another one that was wrong as well. So it's like, yeah, you think that it's one thing, but it can help just with the entire quality assurance of the project. So that's my builder story. And then one last story. Literally the very first time I tried using an exhaust hood, it was a side mounted Panasonic fan. It's rated for that. And it was like not pulling much CFMs at all. That was the thing that I knew I had, but I had no idea what it was. So I had to learn how to use it. You put it on the wall, it's giving a terrible reading. It's like, what's going on? That motivated me to learn how to pull the housing out and figure out what in the world's going on in the electrical connection and all this stuff. And there was like a ridge where the duct discharges. And it didn't make sense to me from the framing perspective. I talked to Ken, can't think of his name, at Panasonic, and he taught me about how these fans work. They're so smart. They can sense the allowable amount of static pressure, and if it's meeting too much resistance, the fan will ramp up to try to give you the rated CFMs that you're supposed to get. So if it's super loud and I've got it clicked over to 50 CFM, it's trying to overcome something. What I've had in the past is the little flappers can just get painted shut. And so I just take a little utility knife and open it up and those flappers go and everything's good. He said sometimes what happens is up in an attic, they'll kind of chain them. And then over time, condensation can form, become liquid, cut that off, and now it's the same idea where you're getting too much pressure and the fan will get loud. In this case, Travis talked about the Instagramming. Thank goodness I video so stinking much. What ended up happening, if this will make sense, it was the exact wrong place for this. You know, you've got your 4x whatever sheet of drywall. You put that on the wall first. Where the duct discharge came out was like perfectly bisecting that seam. So what should happen is you should cut out your drywall, put that up, cut out the other piece, and everything's good. Well, he did it right on the top side, but on the bottom side, he left a hard edge and he jammed it up and crushed that joint. So it was up in that discharge, thereby causing this back pressure problem. And of course, it was all framed in. So under the stairs, I'm in there with a utility knife, the wrong tool. I cut it out. I had the video to kind of show what had happened. And sure enough, it was right there. So I ended up getting the drywall contractor in. He got it all fixed. But I tell you what, I bet you that never happens to him again. And it's not going to happen to me again. But it all came about from the diagnostics, because this is kind of my last point. Yes, I want to build a good house, but part of the reason I try to build a good house is I hate callbacks. Like, I detest problems. And when I first started working for Dad, almost everything I did was a problem that needed solving. So it's usually like, this went wrong, what can we do to do better the next time, type of a thing. So using these diagnostics has, in my opinion, helped us all the way through the process to deliver a home to where we don't have as many callbacks.
And how long did it take you to make that measurement of the airflow from that exhaust fan, Bryan?
Well, considering that was the first time I've ever done it, probably 15 minutes from setup to getting the reading.
Okay. And if it were the fifth time, 5 minutes?
Like, it would take 5 minutes, including getting out of the vehicle and letting it charge up, or, you know, turn on and do its own startup system. It's really fast. What I discovered too is these aren't pushing as much air. Even if you get everything the way you think you should be getting it, don't trust 50, 80, and 100 CFM. Like, boy, that sounds good to have a hard number. Not reality. This is not a Ferrari, you know, it's not highly tuned. All right, Travis. Yeah.
I was gonna say that's a great place to go in and then say, like, so what's in your diagnostic tool bag, right? So I'm a HERS rater. I have a whole bunch of things and I go out and test a whole bunch of these things afterwards. So you said you don't like to have callbacks and do the mistakes. So, you know, this is building diagnostics for new construction. What's in the tool bag aside from the blower door? You said you had a duct blaster, you know.
Yep. Sure. So I have the blower door. I've got the DG1000 that can be used for the flow hood. I think you can use it for room pressures, but thankfully these nice gentlemen have allowed me to have a DG8, which I have not even gotten out of the box yet, but I look forward to learning that. I know that that'll help me out. One of the biggest things is an Amprobe, what's the word, hygrometer? And that has been incredibly helpful to see what your, yes, your dew point, wet bulb, dry bulb, relative humidity, but understanding what those things actually mean and what the enthalpy is inside. Something that can be super helpful is super cheap. It's probably not perfect, but a little RH temperature sensor that goes inside the house. And you can buy them that come with one that goes on the outside and it takes readings of both, just, I don't know, radio wave or whatever it is. So you can go, okay, outside, here's what the humidity level is and the temperature and everything. If you really want to geek out, get your psychrometric chart and start seeing how much energy is in each location. And you might decide, hey, I'm going to leave the windows open now. Construction dryout is huge, especially in the Pacific Northwest. So to understand, I'm just going to heat the house up, open the windows, because sure, it's raining outside. I'm not going to get liquid water in. It's cold enough that if I take this saturated mass of air and replace it with outside, I've just dehumidified my house. Like, so understanding those things I find helpful. I use
Ever
a
seen these
FLIR
before,
camera.
Brian?
Yeah,
Little temperature and RH probe. They're $15 on Amazon, and it'll data log, and then you can send the data log to your phone.
nice.
Everyone's now going to ask you what brand it is.
It is Govee, Govee.
Cool, thank you. I've got a FLIR, I don't remember what the model is of camera, but that is helpful just to use over time and start being able to read and see your bottom plates, what's happening there. I just had a water leak. I don't know if you saw that on Instagram.
Yeah.
And to be able to, look, take a couple of pictures and see where it's pooled in the drywall, in the interstitial spaces. It's not fun to know that, but it's really good to know what's going on up there. What else do I use? I use non-destructive moisture meters. I've got one that's got pins. I've got one that's non-destructive, that's a piece of junk, but I use it anyway. I've got a nicer one that's a surface. The problem with that is you have to have a certain thickness of your material in order for it to actually read what's going on. So like a 2x4, that might not be so good if you're doing it on the flat. I've got a concrete moisture meter that was pretty expensive that you push down on a slab floor. And one of those little trigger temperature sensors, which can be kind of nice to see what's going on. So
That's a
there's
good
the
kit.
toolkit.
That's a good kit, yeah.
What about you, Jay?
And they all come about from failures. Like pretty much none of them have come about because I'm prescient, if that's the right word. And I'm thinking ahead and I've thought, oh, I think I know what may be a problem in the future. It's like, I failed. Now I need to figure out what I need to do to fix it.
I mean, that's how I end up getting any of my tools. It's a failure-based tool acquisition program that I have in my life. Brian, I think you hit all of them. I like having a pin moisture meter. I had one instance where, speaking of callbacks, there was a shower that was not tiled properly, and there was a very large amount of water that was getting into the wall very quickly. And so there was a full pullout, and we were waiting for it to dry. And one person slapped up the surface moisture meter and said, "Yep, we're good to go. Let's seal this puppy back up." And I said, "Hold on one second." And I did the pins, and I was like, "We're going to give it a couple more days." So the pins in non-destructive is awesome, but I think being able to see what's going on inside the wood is also really nice. I think the other one is just, because we're chasing leaks a lot. So any sort of nice fog buffer goes a long way to chase stuff down. We were in an older house, again, kind of a callback scenario, but just looking at I've always heard that, in kind of the 50s styles houses where they did the crown kind of plaster molding, and like the one nice room had that and everything else had, square corners in it, that leaked more. We were up in an attic, and I actually got all the insulation out of the way and was using that to compare the two. And yeah, there's something about seeing it and seeing how much it leaks, and then kind of anchoring that in your head that, yeah, I'm really going to watch out for that detail, now in the future.
So
You
Jake,
can't show things and not tell people what they are. So now you have to tell everybody what your smoke.
This
Ted
is our owner, Gary Nelson, made these. If you don't know Gary, he's awesome. And he's an inventor. He tinkers. So this is a vape pen in the middle here. This is a turkey baster, and these are all parts. And this is a couple years of engineering, so that stream of smoke is perfect for not. It's great. You run that across a leak, and it's not. I mean, when I started doing diagnostic stuff, the smoke pencils that we were using were highly corrosive. You always had to keep them in another bag and keep them away from your tools. And this is using, like a glycol, edible grade glycol. So it's just a really cool, inexpensive fogger that you can use.
Yeah, and if you don't want to make your own, I think they still make them. I haven't bought one in a number of years. There's a little thing called a wizard stick. It's actually a
Yep.
kid's toy. It uses glycerin, kind of
Yep.
does the same thing. But I will tell you, if you get moisture in it, it doesn't make smoke. So be nice to your diagnostic tools.
Yeah.
The
So-
wizard stick
And watch
doesn't have
the
years of
kids
engineering
because
in
they
it.
steal them.
So Brian mentioned the FLIR thermal camera and the blower door, but Jake, do you want to explain to people why you need to use those two tools together?
Yeah, I mean, it's going back to the basics of that, you know, when if you have the right temperature differential, you know, more than about 10 degrees from inside to outside, those infrareds, that's kind of getting into their range where they start working. And you're going to see temperature change that's going to be a combination of thermal bridging. And if there are big leaks, you'll see that all kind of combined. You get kind of an all-in-one shot. If you go through with an infrared camera and take a look at a house in that state first, get an idea of where the thermal bridges are, or maybe you might be seeing some very big leaks in combination, you know, well-established leaks and thermal bridging, and then turn the blower door on to a light pressure to start moving air through, and you can pressurize or depressurize. In our climate, we definitely know it's cold outside in the winter. So if we depressurize, we're going to pull cold air in. Give it a couple minutes, start walking around the house, and the picture-in-picture function on the nicer cameras are fantastic. Yeah, there's a great example there. Looks like is that a wall top and a top of a window there? Yeah.
That was one of my water leak pictures.
Oh, that's
I'll
a
show
water
a
leak.
couple of them while you're talking. Yeah. Now
Yeah,
I get PTSD.
Yeah.
Thank you
Go
so
ahead.
much.
Yeah, and then you'll be able, if you do the before and after, you'll be able to note where you see big changes, and you'll be able to then identify that is specifically an air leak, that the blower door is exacerbating and pulling that air in and cooling down the air. So it helps you kind of parse out thermal bridging versus conductive loss. And then as Brian points out too, moisture. I mean, that's a great one. Yikes. And so once you've done a bunch of those too, those patterns start to, I saw Anthony Cox is on here. Anthony's going to, folks who do a lot of this stuff, you're going to recognize those patterns right away. When there's an air leak, it's this long kind of fingers. If it's coming through a thin little crack, you'll see a long wispy finger thing. Brian's showing moisture there, which is these big blobs that don't seem to be connected to other things. They're pooling water. You kind of start to get another kind of sense for what those leaks are. That's another type of leak there. Yep.
So it amplifies the leaks, number one. But the other thing is, when a house is just leaking under natural conditions, half the leaks are leaking air in and the other half are leaking air out. And when the air is leaking out of a hole, it won't change the temperature. And so if you don't have a blower door, you can't make all the leaks leak in and see them all. So you can only see half the leaks without a blower door.
That's a great point.
I think everybody should have access to a blower door. I say that a lot. And it's good. You meet code, you see what your air leakage is. We actually discussed this, I don't know, last week, 2 weeks ago on the BS and Beer show about how, it's a number. It's not necessarily relative. It's not going to leak the 20-mile-an-hour wind on all sides of your house at all the time, but it's a great metric for us to use to identify these. I'll throw out there that the infrared camera is a great tool, but it needs 5 to 8 degrees of temperature difference, right? So we're not out there using this when it's the same temperature inside as it is outside. And so one of the questions that I think was pre-populated before this was, when do you do blower door testing during construction? And then if you're doing it during construction and let's say it's not during heating season, right? You've got your shell up, but you don't have anything else in. There's also the full fog machines and other reasons that you would do testing. So I think let's expand on what else the blower door does, because you're right. It's not just a leak detector. It's a great resource through construction.
So in my opinion, you can just feel a lot, to be quite honest. If you use the back of your hand or your face, you're going to feel air coming through. So the thermal camera is fantastic to have. but you can just take care of a lot of leaks as it is. I hate to say it, but a lot of it comes down to learning lessons from house to house. And so, for example, one of our big ones is our fireplace inserts. Those are awful, you know, and yet you're dealing with a combustible appliance. And hopefully I don't get booed off the stage here. I would rather not burn down a house than save some energy. I'm just kind of against house fires and killing people.
That's an indefensible
But
position.
knowing that, say that again, Travis.
It's an indefensible position.
Yeah, I know. But it's good to know that, and it also, we're a spec builder. It's a big deal, you know, as far as the ambiance of a room and architecture. So it lets you go in with both eyes open and say, what can we do to mitigate this while still maintaining our vent clearances? So in the past, I think the fireplace companies used to just chainsaw a hole through the back of the house. Now we actually frame in where they're supposed to be putting their discharge, which in this case, it's an intake and exhaust. So doing a few houses and walking around helps you to put better practices in places for future builds. So it's not quite as big of a deal. I'd like to hear Travis's opinion though, because he is a fellow builder.
Yeah, I totally agree. I think that's really the magic of this tech, is making it available and utilizing it multiple times during the build process, specifically to locate and solve as you're moving through, so that your expensive problems become affordably solved early on. And then you're delivering comfort and performance at a very affordable price, which is one of the things that I respect about Bryan as a spec builder. It's not a race to the bottom for Pioneer. You guys are delivering a pretty high-end product on par with other custom builds. You're just making the selections for people in advance, which a lot of people appreciate. For us, we use the blower door directed air sealing measures. We just got our fancy smoke baster, which is what I want you guys to call it. The smoke baster just sounds cool because, you know, I'm in KC, it's barbecue country. A smoke baster is a tool everyone wants. And now I can use it at work and get paid to use it. So the smoke baster is new to our arsenal, but I think that is a tremendous resource. Although I do like the idea of Bryan sniffing around the baseboards to try and find those leaks. I think that's a very respectable position for a quality home builder, to be face first into the corners of every crevice of his home. That's very nice. We also do a fair amount of just visual inspection that tools are beneficial for, but you're confirming what you probably already know. You should have done a better job sealing that, and now you can see that you didn't do a good job, so go ahead and fix that. The thermal imager that we use is a $200 iPhone attachment. It's from FLIR, but it's still the base model. And yeah, if you've got 10 degrees of difference, you're for sure going to see all the failures, and you can jump on it right then. So there's no good reason not to invest in the tech from that entry level position. The stuff that I was excited about learning from you guys is all the things that I don't know about. Like, I think that in this community, most folks already are pretty familiar with, the basic blower door setup.
Wait, nope.
No?
Because you just saw in the chat box. All right, here's your opportunity to weigh in. I think I know how this is going to go. RetroTech or Minneapolis?
I'll answer that one. Minneapolis. Because of Jake and Gary Nelson.
Did you guys read the bio about Steve and Jake? I mean, they're pretty impressive guys. And then it comes to me and it's like, builder. Like, thanks, Fine Home Building, BS and Beer. My bio is like this big, and these guys are like serious engineer types. No, I went with Minneapolis blower door because I didn't know any better. Having said that, I'm thrilled that I did. I've heard, is it Gary? He was on
Gary was
the Unbuild It
founder,
podcast.
yeah.
There's so much behind him in the company. And then I spent time with Steve and a different gentleman. It wasn't Jake.
Bill.
I can't remember his name. I apologize.
Bill Graber.
Bill.
Yeah, and he's responsible for the bios. That's why Jake and I have great bios, because Bill wrote them.
Can you have one for Bryan?
Yeah.
Yeah, we'll get Bill on that, Bryan.
But I like having and I honestly haven't looked into RetroTech. It's kind of like, you know, obviously Travis is an Apple guy, not very smart, but that's okay. He's not going to jump ship and come over. Just kidding. But knowing everything that they have is really helpful for me, so that I've just got one toolkit and I can use it for a variety of different things.
I have dealt with Sam Myers at RetroTech and found him to be very helpful. I think they're a very professional outfit. I don't think you can go wrong with either equipment as long as you're using it properly. You keep it calibrated, which I'm sure you guys can speak to the importance of that. But I know Randy Williams was very formative for me in listening to him talk about the different gear, because he's a gear guy. We should bring him on. He could talk about all this stuff. But in using both different platforms, the advantages of both, I mean, you really have to be pretty high level to get the full use out of either kit. I think there's something to be said for having access to the tech support and kind of knowing. I mean, Randy's in Minneapolis. Of course he's going to go with TEC. But I would like to just be fair that Sam at RetroTech has been excellent to me, and I found his gear to be excellent to use as well. So I think you should be using the gear. And that's the moral of the story. Get gear that you understand, know how it works, keep it calibrated, and use it often. And then talk to Steve and Jake, and they'll tell you why theirs is better.
Well, yeah, to you know, Randy going with the hometown team, let's talk about Bryan Uhler.
That's true.
And Brian's in Washington State, where RetroTech is based, and he went with Energy Conservatory. So you never know. Yeah. But I'll echo, in fairness, what Travis said. Having any blower door is way better than having no blower door. I can't quibble with RetroTech's equipment. Really, it works fine. And the most important thing is to make the measurements. Yeah. As our founder, Gary Nelson, said, it's about getting caulk in cracks.
Yeah. There's been a lot in the chat. Maybe I can comment to that a little bit about the money side of things. So here's how my brain works. And this will answer Randy's question too, as far as if I can self-certify. So the IECC allows in the testing protocol that it can be self-performed as long as it's permitted by the local authority having jurisdiction. I don't know about you, but most inspectors in our area couldn't care less about the certificate of air changes per hour. However, I have been very upfront with them. I get along with our inspectors, so it's not really an issue. But I have geotagging turned on my camera. So I actually videotape when I'm doing the test, so that if there's ever a question, it's obvious where I'm at. I would like show the room, show out a window, just in case there was a question. Well, interestingly, that's now part of the Washington State Energy Code, is you have to demonstrate that this is where you were at. Why? Well, the very first story I told is people falsify their records. So I was doing it as kind of a fail-safe just to be safe, and then it turns out that that makes a lot of sense. So for us, I don't know what it would cost, but let's just say as a contractor, which might be different from a homeowner, if it's $300 a test and I've spent $3,500 for the equipment, in 10 to 13 homes, somewhere in there, I'll have paid for it. And I'm the one doing the work, and I can fix the leaks myself.
That's
so
the
it's giving a better
element.
Product at the end of the day.
Yeah.
It's, you know, we build 4 to 5 houses a year. So if you take a longer term like the Europeans for a payback period, it's not that big a deal. But if you're doing a one-off, connect up with somebody who's got a blower door and then just hire them. $1,000 a house to not own the equipment is going to make a lot more sense. It's like buying a piece of equipment to dig in a sewer. Don't pay $150,000 for an excavator. Rent it for $1,000 for the week or whatever the case is. So just kind of think about what you're trying to get out of it and make the smart decision there, is my opinion.
Yeah. That's a
Also,
really, that's a really heartening position to take, Brian. I want to mention a story from our founder that's related to what you just said. When Gary started the Energy Conservatory in the 1980s, he figured that making a blower door easier to use and much cheaper. Before the Energy Conservatory, a blower door was like a research tool that took all day and took like $10,000-$20,000 to obtain one. He made it more accessible by making something practical, easier to use. And he thought that as a result of that, every builder was going to want to have one because they would want to make better homes. What's happened in the intervening 30 plus years is that there's a whole new industry of energy raters and companies that are focused on doing the test for the builder. And it has sort of robbed the builder of the learning that they could do if they had one of their own. And so it's, finally, Gary's vision is becoming reality, that builders will actually be able to have the tool to learn, where are the cracks getting introduced? How do I fix them? What stage do I need to be worried about things?
Mm-hmm.
And so it's really encouraging and heartening to hear that we're finally getting there.
Yeah, I thought, Bryan, your story was really awesome. Like, you're using it, you're learning from it, and the type of learning that you get from reading a spec sheet and saying, oh, that fan flow rate is this, versus a tactile, no, that fan flows this, under this condition and this under this condition. I mean, the level of knowledge you get goes so much deeper by having those experiences. So yeah, I think that's awesome. And Emily, you'd asked earlier about, like, where else can you take this stuff, and I don't want to go too deep into it, but I think, if you get to a scenario where you've failed that ACH 50, whatever it is in your area, and you need to go find the leaks. Bryan, have you done anything with zone pressure diagnostics to try to pinpoint where those might be?
No, but when I was talking with, who was it again? I'm sorry. Who's the other gentleman at
Bill Randy Williams? Oh no, Bill Graber.
Let's just
Bill
keep
Graber?
talking at exactly the same time, Travis, over
Bill
and over.
Graber, Bill Graber, Bill Graber, Bill Graber.
Yeah, I think when I met with him and Steve, that was part of the reason I wanted to do this show. Is I don't know enough about that. I think Mike Gerton has talked about it. Yeah, so I don't, but we are now putting like transfer grills between bedrooms in the hallway. We've gotten more sophisticated on our HVAC ducting side, just to try to have more even heating and cooling. I don't know how big of a deal that is, given that we're using such small mini splits in our houses anyway. It's not like they're all on or all off. They're, just kind of sipping energy. Maybe you guys have input on that.
Yeah, so you can still run into problems with that. I'll mention a couple different things that you can measure beyond the basic blower door test. The first one is zone pressure diagnostics, and that is a method that you can use to find out, okay, I've got too much leakage, and by doing zonal measurements between the main house and the garage, and or the main house and the attic, I can get a pretty good estimate of how much leakage is through the ceiling to the attic, or how much is through the wall between the garage and the main house. That allows you to pinpoint, and spend less time doing the ceiling once okay, it looks like half my leakage is in the ceiling. Well, let's get up in the attic and let's focus on that. The other thing that
really quick, Steve, just to key off that, we were in a house recently, and leakage to the garage, once we did a zonal test, about 7%. Leakage to the attic, over 50%. So when you're doing the type of zonal pressure that we're talking about here, is you can pressurize or depressurize. You've got the blower door already set up. You take a pressure reading, say you're depressurizing the house. You take down the attic zone pressure with reference to the outside, the house with reference to the outside. Take the hatch off, do the same test again, take those measurements again, and get the blower door number. It's 6 pieces of data at the very, very least. And we were using a free online calculator that Rick Card makes, Red Calc. Punch the numbers in there, and it's very fast to be able to do that. And it's got a plus or minus, so it's not an exact thing. But you can use that and go so much deeper on that. It gives you some idea of what the holes between the outside of that zone and the outside are. So in that case, in an attic, it's giving you some estimate of what your actual ventilation the size of the ventilation, roof venting is. So it can get kind of oversold sometimes, and you need to understand kind of its limitations. But it's a really good, quick test to be able to kind of focus your efforts in a situation where you might need to be doing some extra air sealing later. So,
Yep.
sorry, Steve, what were you saying?
Yeah, so I'll just mention one thing. Zonal pressure diagnostics, if you actually want to understand how much leakage there is, it's a two-step process. I've seen, some informational sources are explaining a process that's only one step. You only measure the pressure once. That can tell you only a ratio, and it can't actually tell you how much leakage there is. So it's a two-step process. Make sure you're making that distinction. The other thing I want to speak to is what Bryan just mentioned about room pressurization. And, is room pressurization a big deal? And the answer is it really can be. Room pressurization happens when in bedrooms, usually, there's a supply and there's no return. And when that happens, if there's enough air going into that room and there's not enough leakage between that room and the main part of the house where the main return is, you can pressurize the room. And how much you pressurize it depends on a lot of things. Depends on, how much air you're putting into it. And like Bryan said, if it's a very energy efficient house and there's not very much flow, there's probably adequate leakage under the door, around the door cracks, under the baseboards and so forth. But you don't know until you measure. And so with a separate manometer, or you can use the same one that's running the blower door, you kind of have to disconnect and reconnect a few things. All you have to do, so room pressurization is not done with the blower door running. It's done only with the HVAC running. And all you do is you toss a hose under the door to a bedroom and close it when the HVAC is running. There shouldn't be any more than about 2 pascals difference between any room and the main part of a living space where the main return is. If there's more than that, what it means is you're actually driving some of that conditioned air out through the cracks in the exterior walls. And the main part of the house is usually going negative pressure if you do that. And so the main part of the house is sucking in from outside and the bedrooms are blowing out. And the result of that can be big humidity problems in humid climates, because what happens is you can get many, many more times more infiltration than happens if you have all the bedroom doors open. So at night, you're driving this crazy amount of infiltration and you wake up and it's humid in the house only in the mornings. So pressure imbalances are a big deal and they're not that hard to diagnose, but you just need to walk around with the manometer and the HVAC system running and start measuring pressures from room to room.
And for all the frightened builders who are now worried about having to solve this, you could solve it the cheap way and just cut the bottom of the door higher. You can undercut the door and make this work. You don't have to rip off all the siding and create an actual air barrier, or, God forbid, go in the basement and seal the rim joist. You wouldn't want to do that.
Well,
and I think
so this one, the solution to this is undercutting the door, or usually a jump duct, through the ceiling from the bedroom to the hallway usually, or sometimes they'll put a transfer grill in above the door. The ceiling won't actually help this usually.
And I was going to say, one of the things that we didn't really talk about in the diagnostic toolkit is in new construction, we still have combustion appliances, right? And so room pressure can become really important if you have a combustion appliance, right? Because you can walk through the whole house and you can change the amount of air that's getting to your combustion appliance, and your negative pressure, although it could be bringing moisture in, which is, its own big problem. You also can be bringing in combustion gases. If you've got a water heater that doesn't draft really well on its own, or, I'd like to think that our really high performance houses up here in New England aren't putting oil boilers in that are atmospherically drafting, but that still happens in new construction, right? And so we have to be careful with combustion appliance zones, even a gas range, right? You can be introducing that. And so, in my diagnostic kit, I also have a carbon monoxide alarm and a gas leak detector, that goes with you too. If you have those things, once we electrify everything, some of those things will get less scary, but until then.
Yeah. For more information, look at our YouTube channel and you can see the webinar we did where I backdraft my water heater in a webinar. I'll show you how that works.
I have a pretty big. basic question, but just in new construction, when do you blow a door? What are the ideal, what's required? Just what are the basics of new house blower door testing?
I'll answer from the way we do it, and then I'll be curious to see what Travis does. I blow a door, when do I do it? Actually, at the end of the whole project, because 99% of the time I use aero barrier now. And so in a technical sense, it's blower doored at that point. I am trying to I have to really pay attention to labor productivity. You know, I don't get actually mathematical about it, but I know what production means. And to be sitting around trying to seal everything up doesn't make sense for me as a small builder who wears, I'm just going to say, so many hats, and I'm not finding a lot of people who can come in and do a lot of work. So whatever I can do to take off of our plate, it's safer. I'm not crawling around the attic. You know, you've got a fall hazard. Every time you get on a ladder, you're asking to get hurt. If you follow me on Instagram, every time you strip the foundation, you might smash your face with a pry bar and go to the emergency room. But anyway, that was last week. Anyway, so when it comes to the envelope minus ducts, that's how we do it. When it comes to the duct leakage testing, and I'll tell you just one more story. It looks like it's going to go through, but we have a house that's under contract right now. It literally appraised for $100,000 less than the sales price that was agreed upon. So that deal was about to flip, and we've held it together. It has taken a lot of, that's a topic for a whole nother thing. We can't just keep putting money into our houses, is the bottom line. So people can say all day long, bring your ducts in conditioned space. I'm a spec builder, so that's a great idea. I'm in climate zone 4C. It's relatively temperate. So putting our ducts in the attic where all the ducts are insulated, we're using VRFs, our building envelope will blow between a 1 and a 3 at the end of the day. We're gonna be just fine. It's not the end of the world. So usually we'll put our attic blow on the ceiling or the attic floor, the ceiling of the first or second level. You don't want to be horsing around with leaky ducts after you have insulation blown in. So I like to do it during framing because you can really access all the ducts pretty easy. We're builders. I have to get on a ladder from time to time. I just try to minimize it. So it's easier to get between joist bays before there's drywall. On the other hand, I can do it at drywall, and that's fine. But my big thing is just before attic blow, if that's the way you're going to be insulating your attic, just so you've got good access to everything. And then I do it at final, following the protocol for that as well, where you can actually tape to the grills and see what's going on. And you can still fix things from the underside because you really get to understand the whole duct system and how the boot comes in and the framing that goes around it, all of that stuff. So that's what we found are the kind of the sweet spots, because we have ventilated attics, passively ventilated 99% of the time. And we also have passively ventilated crawl spaces. I know, they go pretty crazy, but same idea. Our air barrier is not going to be like somebody in Texas who has a concrete slab and has spray foam in the attic. It's different. So we have to do it in a different way.
Yeah, at a very minimum, Michael, you have to have enough of an air barrier there that you can get a pressure. And you don't necessarily have to get to 50 pascals. You can have big holes. You could have, I've seen people tape off, a window gets pulled for some reason, or their window's not in yet, where they'll tape some things off that they know are going to, they're understanding they're not testing that part, but they're doing it like Brian's saying, this iterative process while you're building before, like he said, spot on. You can do that before the insulation's in. You have a great learning opportunity for everybody because you can get up there and actually show them where the leaks are. So yeah, I think at a bare minimum, that's what you got to be able to hit. But it's really going to depend on the build of the house.
Let me make a summary statement there. So The one for code inspection usually has to be done at final. Everything has to be complete. People are done drilling holes and everything's complete. But this crowd is probably most interested in learning from the blower door test. And so then you want to do it as soon as possible. And if you're just getting a blower door test done for the first time, you might want to do it 5 different times during construction so you can learn when and where are the problems, when are the holes getting created.
Yeah, I'd agree with that. I think that the tests that we've done, most recently, Randy Williams came down and did a couple tests on one of our builds. And then we subsequently have had a HERS rater out, a different HERS rater. Randy's obviously a HERS rater, but a local one who's doing all of our Energy Star stuff, which is a point I wanted to bring up earlier. If you are interested in getting money to pay for your testing, the government will give it to you if you qualify. So we're paying for our HERS rating on one of our current builds with a tax credit. Actually, I think it's the new home builder tax credit through Energy Star. It's a $2,000 tax credit, if I'm not mistaken, and that's going to cover my HERS rating. So nice. I'm not making any money on it, but I can also, turn that into advertising and prove to my clients that I build a damn good house by someone else's metrics instead of just showing them and telling them.
Or you follow them around and you learn all the things that they just talked about what you do. And the nice thing about the HERS rater, right, as there were a lot of people talking about how expensive it was just to buy a blower door. When you have a HERS rater, they usually also come with a whole lot of other diagnostic equipment. So if you're just getting into it and trying to determine, till you get to the point where you're like Bryan or Travis, where you have multiple things, if you're just getting into it, have one of them come learn what techniques they use, find out what testing equipment they have, and then use the ones that make the most sense for you. Like in Maine, we don't have as much ductwork. So I very rarely would use a duct blaster. We just don't have as much ductwork. We test our ERVs, which is different, but so there's lots of things that you might have that's specific to how you build, and maybe you don't need all of those things, but it's great to have a HERS rater come. It's also a great way to learn how to use your blower door if you've got one and you have no idea how to use it. Like, get the state to pay for it that first time and learn. So,
well, go ahead, Bryan.
Oh, just a couple of things. I think with your duct leakage, at least in the past, and maybe it's a Washington State Energy Code thing, you could take a duct leakage test. And I thought even the envelope earlier in construction, you didn't have to meet the same level of airtightness as at the finish. Anyway, that's more just a matter of meeting code or beating code or, whatever the case is. And I don't remember what the second thing was that I was going to say. Sorry.
Well, I'll continue my just quickly to follow up on what Bryan was saying as far as his process. We would be satisfied on most of our builds with 2 blower door tests, ideally 3, but we use zip systems. So what we would like to do in an ideal situation is go ahead and sheet over all of our window and door openings. Of course, you can't do that. You have to get into the house to work, but we leave them all sheathed. And then that would be the first test for me, ideally, because that's going to show me anything egregious on the exterior skin, because that's what I'm using as my air barrier for the most part. And then we would do a second one after we've installed the windows and doors and done all of our mechanicals prior to installation. And then we would do one final. So just to follow up on that question from earlier, Bryan, that's how we would prefer to do it. We're moving somewhat away from using our drywall lid as an air barrier. That's a work in progress. We just found it to be a little bit more challenging in terms of time and money than we had expected. And so we may continue to manipulate that. And that affects, obviously, when we would do that secondary test. We don't have to test for duct leakage in any of the jurisdictions I'm working in currently, although I think 2 have adopted the 2018. So maybe that's about to change. But all of our ducts are always within envelope. We do a lot of crawl spaces, but we don't ever do a ventilated crawl space. And Bryan and I've had that conversation before. His climate, it makes totally different sense for him. In our climate, even though we're 4, every time I've worked in a home that had a ventilated crawl space, I've seen nothing but mold and pest infiltration in that ventilated crawl space in my market. So we react to that and we do condition crawl or a full basement on all of our stuff. And so all of our ducts are within the envelope. And so we haven't been doing any duct leakage testing, even though Steve rightly pointed out, there are plenty of comfort issues that result from that lack of testing. There's typically not a code compliance issue or what I guess what you'd consider performance. I want to say that comfort's a function of performance. I want to tie those back together. I think we should do it right. And we seal our ductwork manually because it's part of the code, but we're not testing to verify that. So I guess we can't get credit for it under the basic model, where if you can't prove it, it doesn't exist.
Yeah.
Well, and I don't know which code version you have on it too. And it might actually be a function of code, just not then the performance metric, right? Too is like, you know, you have to be able to verify that the amount that you're giving to a certain area, right? Like they're actually kind of sticklers about that. And it can be a durability issue that we just don't associate with it, because checking positive and negative pressure isn't obvious unless you're checking your ductwork. So.
Yeah, for our energy modeling, we're delivering very specific CFM to different places in the house so that we can actually use a smaller bunch of equipment. If we're not delivering the proper CFM to that space, it's not going to be comfortable. And so we're meticulous in the duct sealing measures, but we aren't testing. So I guess, like I said, I don't get credit, but you're quite right. We're very specific about that, but for a different reason, not to satisfy an inspector.
I remembered what the other thing was I was going to say.
Can you do it in Spanish?
See,
We'll see.
that's it. In Washington, they're changing your square footage to, or your cubic volume from whatever your actual height is to 8.5 feet, period, times your floor square footage. So if you think you're going to be getting a bunch of credit for having this giant vaulted great room, negatory. So I'm part of that test thing that I'm doing is showing the difference in what the blower door result would be depending on if I'm using the 2018 or the 2015 code. It is way, way tougher if you're just using an 8.5 foot ceiling height. So it's worth it even to run the math with your hand, in my opinion, and kind of see what you're getting yourself into and how that equation changes depending on what the inputs are. So knowing what your cubic volume is can make it much more difficult to hit your target number. I was going to comment too, you know, Travis did a nice job there. So my dad started the company in '78. We have never had mold in a crawl space. But we are in climate zone 4C. We're cold in the wintertime. You know, it rains, but there's not much water vapor. So we just don't get much humidity. We get humid in the summer, but it's not bad. Where we get stung is if we have our elevations too low on a site, like this is more civil engineering stuff. If we don't take care of our gutters and downspouts, that's where we're going to have problems. What we are though is high seismic design category. So I'm going to get on my soapbox for just a second. So we have to do like seismic hardware, lateral analysis, that type of stuff. I think it would be kind of ludicrous for me to expect somebody in another part of the country with a low seismic design category to build to that same level. So I'm a proponent of understanding exactly where you're building and what the different loads are that you're trying to account for. So if you're a mechanical engineer, you've got loads, you've got the exterior, your interior BTUs, all of those things. If you're a structural engineer, what's your soil type? What are you expecting by way of seismic? If you're in Miami-Dade County, what are your wind pressures going to be? The more we can take that holistic approach, at the end of the day, that house is going to be better for that area. The earth is just too complicated to me to try to build with a one-size-fits-all methodology. So I think it's just good to consider all of those things. And that's one of the beauties of Instagram, is we get to see different methods of building all over the place. And at first it might, like, you know, our brain might recoil a little bit because, well, that's not how we do it here. But after we think about it and understand the reasons why, and maybe it should change, but at least we don't start from that perspective of, well, that's not how we do it here, so that's a foolish way to do it. But be maybe a little bit more open-minded. I'm off the box.
Do you want me to do the Spanish part for Bryan, since he You whiffed on it.
Sí.
Ok, muy bien. Voy a dar bienvenido a todos que hablan español y quiero decir que para escoger el equipo de quien va a fabricar el blower, por favor de escoger nuestro equipo en Minneapolis porque es lo mejor y porque el presidente habla español.
Very good.
Did
very
not
good.
mention that Steve is fluent in multiple languages in his bio, but I think he's demonstrated that, and that's perfect because this is a diagnostics and testing show. So of course you would prove it. That's perfect.
Yeah.
He really keeps us on
If
our
it's not
toes
on
at staff meetings.
Yeah. if it's not in video, it didn't happen, right?
That's right. I wanted to ask you guys, I don't want to diverge too much, but there was a piece of tech that Jake had at the symposium, the DG8, and I kind of got like the 2-second introduction. And I think Bryan was talking about how he's got one at home, and I don't have one yet, but I want to understand what I'm missing out on. And I don't want you to do a commercial. I just want to know what it is, what it does.
So
DG8, it's a 1-channel pressure, a differential pressure gauge. So most of the ones that you see for a blower door have 2. This is 1, and the one we make here is just really simple, and it's inches of water column and pascals, and it's got an on and off button, and you switch there, and that's it. It's
So
very, very straightforward. Yeah.
the reason we created this is because a blower door manometer with 2 channels that does all the calculations of flow these days is upwards of $1,600. But we recognize there's a need for a simple pressure measurement that's just as accurate. So this has the same accuracy, but it only has 1 channel, and it's only for measuring pressure. So when we talked about zonal pressures or room pressures or combustion appliance zone pressures, or HVAC technicians can use it for duct pressures. Anytime you're just measuring simple pressure, this one's $550, so like a third of the price of your blower door manometer, and just as accurate for just measuring simple pressures. Somebody's asking, accuracy on the DG8 is the same as the DG1000.
When Bryan was talking about the fan flow, same thing with the exhaust fan flow meter. You can go around pressure pans, flow meter, stuff like that. So,
So if you had let's say you had a site-built pressure pan, the piece of plastic with the tape around it, and you wanted to go ahead and insert that into one side of the DG8 and then compare that pressure to the room in a very non-scientific or palatable test method, could you actually use this DG8 to determine the flow of these lesser quality appliances?
So a pressure pan won't tell you flow, but yes, you can measure a pressure pan pressure with this.
Well said. Thank you for the correction.
I was gonna say, they make a really nice flow hood that has a really nice handle for us short people as well.
There have been a couple of questions or comments about basically whether ACH is a good way to test quality of a house. Is testing the airtightness of the sheathing area better? How would you test the sheathing area versus the cubic volume?
There's a couple different ways. So the most important number that I think everybody agrees on is the CFM 50 number. And that's just how many cubic feet went through the blower door at 50 pascals. That one's important because it's simple, it can't be gamed. But the problem with it is it doesn't allow you to compare a really big house to a really small house. And so in order to compare a big house to a small house, like you have to do for things like building codes, now you have to decide, okay, are we going to do it in CFM 50 per square foot of floor area or per cubic foot of the volume of the house? And when we compare it to the volume of the house, that's how you get ACH, air changes per hour at 50 pascals. So you take the volume coming in divided by the volume of the house, and that's air changes. It is, I would say, a reasonable way to compare houses of different sizes. But if you really care about getting it right, you really should be more concerned about your CFM 50 and less concerned about exactly how it gets normalized. there is a weirdness about ACH 50, and that is there's the cubed squared rule that has to do with how volume of something relates to its surface area. And what that means is that the bigger the building, the lower your ACH 50 is going to be, even if you have the same number of leaks per square foot of shell area. So the codes that apply to larger commercial buildings never use ACH 50. They all do, they all normalize by the total shell area of the house or the building, because ACH kind of falls apart when you get big.
Got it. Thank you.
That's ultra nerdy distinction for many folks, but I do think it makes sense because you frequently hear people talking about gaming the system by building bigger houses to get that bigger volume. Like, oh man, I got this 14,000 square foot passive house, because I hit 0.6. Like, well, yeah, I'd like to see you do it on that 900 square foot tiny house. Let's see if you get those same details, nailing it that way. It's a different animal, and I've benefited both sides. I have big houses and little houses, so I get it.
You're looking for a tiny little leaks on the little house, aren't you?
Yeah, you got to really nail the details to get those numbers low. And so you always respect the guy who's like, oh yeah, I got it on the little ones.
Yep.
One other diagnostic thing, and I haven't actually done this yet. I'm sure that the Energy Conservatory guys can speak to it better. But also in our code, we're supposed to be testing our ERVs for their flow rates. Like I say, I haven't done it. I've just rolled forward because literally all of our permits are 2015 vested. And so I have to be efficient. It is what it is. Yes, Travis, we buy our permits before the new code gets adopted. And
6 years?
Well, remember it gets adopted.
Oh, I
and
see.
Then
I heard you. I misheard.
Yeah. And then you get COVID happen, which can allow you some extensions. You can call it gaming the system if you would like. So the bottom line though, I'll get off on that tangent. Doesn't mean that we wouldn't build to the 2018 code, because it could be that that's what everybody's building to anyway, but it gives us some flexibility. So for me, there's these little ports on the Panasonic IntelliBalance 100, and I'm guessing you just insert the probe in there and see what the flow reading is that comes out. How does that work?
So I think that's a hot wire anemometer that you described. And measuring flow on ERVs is kind of a can of worms right now. There's not, in my estimation, a really good way to do it. And so the problem is that a single point in a 6-inch duct, if you're anywhere near a curve or an elbow, is not going to be very accurate. And so whether you measure that with a pitot tube, which we have some of our customers do, or a hot wire anemometer or a mini vane anemometer, if you do a single point in the middle of the duct, it's not good enough to get, you're not going to get better than 10% consistently unless you have a lot of straight duct and it's really straight. But so an averaging pitot tube, this is a device that TruTech Tools sells, is probably better than a single point. You can measure, if you can get your exhaust fan flow meter or a powered flow hood over the intake and exhaust on the outside of the house and get them to seal well, that's one of the best ways to do it, the most accurate way. But there's not, then the other possibility is many of the manufacturers will put pressure ports in. You'll find 4 pressure ports, and you measure the cross pressures and look it up in a table, and that'll tell you how much flow you have going in and how much flow you have going out. So there's several different ways to do it. None of them are foolproof. Probably the most accurate is with a powered flow hood on the inlet and the outlet on the outside of the house. Yeah, and there's
I wasn't disagreeing with you there, Steve. I was just trying to make an adequate joke for
Oh.
regular viewers of the show. You're obviously right. Well, we're kind of toward the end of the show. This is usually the time where we sort of go around the horn and final thoughts. How can we help people? What's the right direction? What little tidbit did you want to share that I didn't allow you to because I was talking too much? All of those things happened at this time in the show. If anyone's dying to get something off their chest, now would be a good time before we run out.
I was also going to say there was one thing that came up that, like what are the common tests or commissioning that we should be doing on every building too? Or like, from your perspective, what equipment are you guys selling the most of, right? Or what are most people adopting? If you're going around the horn.
I'll tell you that the new thing that we're getting a lot of buzz about is we've just created a new true flow. If you're familiar with this product, it goes in the filter slot and measures how much air is going through the furnace or air handler. And this is becoming part of energy codes in various states. There's a new ResNet standard related to this. And to get all the ResNet points, you need to measure the airflow, the duct leakage, the fan watt draw, and you need to evaluate your design on the HVAC and so forth. So we're seeing a lot more interest in airflow through the unit. And this is another case that there's really not a lot of good ways to do it that are accurate. And that's why we created the original TrueFlow 20 years ago. It was a great device, but very nerdy. So we've made the second generation, which is a lot less nerdy, a lot easier to use. And we're seeing a lot of interest in that.
Yeah, I would just throw in there that this sort of stuff, being able to nerd out and talk about this stuff is being in tech support is what I get to do every day. I have like the coolest job in the world. If for the folks that are watching, I suppose specifically if you're using our gear, but call with the questions like this. Brian's like, I'm going to go back to Brian's story at the beginning. Like that is the best way to move this thing forward. Is people doing the tests, falling on their face, learning something else. And you, like I was saying, you learn it in I'm a very tactile learner. I learn it in such a different way when I can put my hands on it and actually know something instead of being told that this is how it works. You get to see it and see the real performance part of it. So I just, if anyone's got questions about this stuff that we can help with, if you're using our gear and not understanding why you're getting your reading, there's a billion different things that, from the setup to the crazy house that you're in to, you're on a mountain and you think you're at the coast. There's so many different things that can be going on. So I would just say, give us a call if you got questions.
Gonna walk you around and FaceTime you for hours on end.
That is by far the best call is when someone can be like, here, let me show you. And now that everyone knows how to use Teams and Zoom, it's actually made doing tech calls a lot easier because you can actually see what's going on.
I'll take the next round then. I would echo what Jake already said. I think there's an easy thing as a builder. What do you call it? Basically, if I'm not aware of it, I'm not responsible for it. There's a phrase, and it's just not quite coming to me that, well, I'm just going to assume everything is fine.
Plausible deniability.
If we want to go the President Reagan route, but then we could say the trust but verify, which is, I'm just going to tell you right now, that's a really negative term. This is so common in commercial construction. Tab reports, testing, adjusting, and balancing. It's just not common in residential construction because we're just trying to get the house done, get the final, and get the house completed. It takes time. And so don't get intimidated by it, but just we talked about this last time I was on here. Every bit of knowledge we get is just a brick in the wall. And then you get to grout it and mortar it and connect it all together over time as you get it from different places. So I don't know if Christoph is still on here. His podcast is probably the best one I've listened to. Just start going through it. Bill's Spones are outstanding. And over time, you're going to get there. But, like I say, structural engineering, civil engineers, they might test percolation rates or the bearing capacity of the soil. That's all this is. It's just testing what was actually there. And by doing that and taking an approachable perspective of it, it gets a lot easier. And if you fail, that's okay too. Like, that's what you have to find out, and then you figure it out for the next time. I'll tell you again, my brother's not listening. So he was supposed to install the ERV caps on the roof. One side's the intake, one side's the exhaust. I don't know how many times we went over this. The poor guy, he's older than me, for crying out loud, so it's even more awkward. So I look up and I can see daylight coming in with the one that's supposed to have the flapper. The intake, you take the flapper out, leave the bug guard on. Timmy, did you put the right one on? And he was just so disappointed at himself. He zip taped it and did everything, so then they had to run back up there. That's part of it. It's the verification of what was actually installed, and we did it before the actual roofing was installed. You know, don't be a jerk if you see something was done wrong, but it's okay. Things might get done wrong. Do your best to fix them and move on. Oh, thanks, Mark.
So thank you all for joining us tonight. It was so great to hear that. And clearly, you know, listen to the podcast that Bryan just said, and then follow Bryan on Instagram and he'll show you all the things that he had to redo. And I think that's the best part about the building science community is we're all out here sharing the failures and the successes. And so that's the best that we can do. So I appreciate all of you taking your time to be here tonight. Building diagnostics is one of my favorite things. And I tried to be quiet, so I didn't talk too much tonight. So we can really highlight what you guys do. So thank you so much for joining us.
Thanks, guys.
Thanks so much. Have a great night.
Great to be here. Thanks for the opportunity.